Welcome back, everyone, to session 2, Green Infrastructure in Action. I hope you all had a great lunch break and just wanted to review quickly our fantastic session 1, which was on the impacts of fires on water quality, where we heard about the work that's being done in the burn areas, how we can make our communities more resilient and reduce the risks of future fires, as well as the work that's being done to repair on with private homeowners. So thank you once again to our fantastic presenters from session 1. And now we're looking at session 2, Green Infrastructure in Action, where we will have several fantastic presenters, 5 to be exact, talking to us about what does green infrastructure look like in our communities. We know that in order to make our communities more resilient, we need to be changing our approach. We need to be looking at these more integrated strategies to make our communities more resilient moving forward. And so we have, kicking off our session today, we have Holly Pisa, who is the Engineering Services Manager for Mile High Flood District, giving us the introduction to this session, as well as an overview of Chapter 4 updates to the Urban Storm Drainage Criteria Manual. Welcome, Holly, and I'll let you take it away. You are muted, Holly. Thank you.
All right, well, hi everyone. I'm happy to be presenting with such great company in this session. Jessica asked me to talk a little bit about what green infrastructure is. There are some attending that are not necessarily stormwater focused, so I'll share a few definitions with you that I like, and this is a good, pretty simple one. Green infrastructure utilizes processes found in the natural environment to deliver sources or services and functions required by the built environment. A lot of times we talk about it being specific to wet weather. So this is another one. At an urban level, wet weather management practices that include filtration, infiltration, evapotranspiration, and reuse in an effort toward restoring natural hydrology. And at the district, we like to also talk about the watershed scale, which speaks to preservation of stream corridors, allowing for habitat and animal passage similar to that found in nature, and designing to preserve ecological function and create balance between the built and natural environment. And the speakers in this session really speak to both scales. And the projects that we're talking about here really serve to both demonstrate and promote green infrastructure. And in the case of some of the work at the National Western Complex, advance the practice by bringing together research and demonstration. And last but not least, Agriburbia is an example of working within the watershed scale to incorporate how the community will benefit from preservation of the corridor and how the community will interact with that space, which is important from the standpoint of the community really valuing what we do and valuing green infrastructure. So what I'm talking about is criteria, which may not sound as exciting. However, the question for Mile High Flood District is how can we, through criteria, demonstrate and promote and advance the practice of green infrastructure. So right now we're updating what I refer to as the heart of Volume 3, which is Chapter 4.
Hey, let me know. No.
Design criteria, and we'll follow that with maintenance, the maintenance chapter, which is also a big one for us. And this is just where we are in the schedule. I'm really excited to be seeing some part of the draft come out in just a few weeks. That will be released and posted on our website. We are really big in the stakeholder process. We consider the stakeholder process to be part of our education and outreach. The more we walk together through changes, the more everyone involved understands the intent. And we are working with kind of a dream team of consultants. We have Brightwater engineers and Dr. Andrew Earls, who you'll hear from as part of this session, doing a fantastic job. Muller, Stream Landscape Architecture, and a number of subject matter experts from Wheeler and Associates, Aware, Geocentech, and Creative Civil Solutions. We've had a number of these stakeholder meetings, and I'll talk a little bit about that. We started off very early and asked a lot of broad questions at first. So things like, how does criteria work for you? And how does it make your job harder? And some of the things that we heard, one of the big things that we heard is that criteria can sometimes be too prescriptive. And in that way, it limits innovation. And we need to balance this need for the local government or the MS4 to have a way to ensure that the design meets the permit requirements, but we also need room to innovate. And the kind of key ingredient for that combination is just a really solid understanding of the why behind the criteria and the intent. So how can we, in the process of presenting criteria, encourage users to make good decisions? How does SEM selection come into play with SEM design? I used to think that these were sequential steps. If you know something about the site, you pick a BMP or SEM and you design it. But there are smaller decisions that become available to the designer through a more detailed site assessment. Things like, are we infiltrating or are we just filtrating? How do we recognize the really good opportunities for reducing runoff through minimizing directly connected impervious areas? So we're exploring ways that we can structure the criteria to encourage the SEMs or SEM combinations that provide the best treatment and hit more steps in the 4-step process, which is what you see here. Step 1, reducing runoff and treating and slowly releasing the WPCD, stabilizing the stream, and looking for source control measures. So currently, we have a very short intro in chapter 4 and a series of fact sheets that go into very detailed design criteria. And the new draft has a much longer upfront section that includes really good discussion on community values, and I'll speak more to that. Site assessment, it walks the user through site assessment, walks the user through making decisions about filtration versus infiltration, and then more detailed information on all the common components, like how do we bring water into an SEM. And that's followed by individual fact sheets still, providing that minimum criteria for review engineers that need to ensure that we're doing this in a way that meets their permit.
Hey, Holly.
Yes.
You're a little bit garbled and we're getting some feedback. So I'm wondering, would you be able to move closer to your microphone?
Sure.
If that's possible.
I could just enter this. Okay, is that better?
Much better. Thank you.
All right, I'm glad that worked out. That was a little scary. Okay, so starting with site assessment in the upfront section, this is just an example, again, of trying to guide the user to start with full infiltration and then move to partial infiltration, line systems, and then, ponds and EDBs. And that upfront section is followed by a series of fact sheets that, again, start with runoff reduction, and then filtration, and then sedimentation-based SEMs. And so I'm not intending to pick on EDBs. EDBs are a great SEM, and they are included in what we consider green infrastructure, absolutely, and they're not necessarily the right choice for every site. And this one that you see here, although particularly adorable, we just never intended EDBs to be constructed at this scale, right? In looking at what we have currently in the criteria, we really do make it pretty easy to go to that default selection of EDBs. And so we're doing that, but it's not until, when we get into the numbers, it's not until we get into a tributary size of 12 plus acres that we're able to do things like move away from this, well screen that you see here that's more prone to clog and move into an open grade. So one of the things that you'll see that's different is some of our sizing recommendations. And that's one way that we're encouraging more filtration and infiltration through bioretention. Another thing that we heard when we talked to the stakeholders in the bioretention group is, when we asked them, what stops you from selecting bioretention? It was a concern for maintenance, which if you go to the fact sheet right now, you'll see some kind of scary language about things that you need to really get right. But the thing is that that concern for maintenance, it's very contrary to what we find in our research. So at the district, we've been doing research on various SEMs since the 90s. And right now we have 4 different studies that we're doing related to bioretention. This is one of them. This is our IRIS site where we're doing full monitoring on the inflow and effluent from this bioretention basin. We also have a similar site at River Run. We have what we call the bioretention research study, which we're looking at bioretention basins throughout the region and taking samples and gradations and evaluating vegetation. And then we're working with Denver on their street-side stormwater planters. And much of the research that we're doing includes collecting data on maintenance of these facilities. But it wasn't until this CASFM field trip, I think in 2014, where I really became convinced that bioretention is one of the most straightforward and least maintenance intensive SEMs. If you get the construction right, it's, for a lot of the sites that we went out to, the owners didn't even know what they had. They removed trash periodically, but the maintenance was pretty straightforward. And if you look, as we go through some of these sites, a lot of what they have in common go back to that community values piece, right? They're integrated into the site. They fit into the site in a way where they're interesting and they're attractive. And what we have found through our bioretention research study is that when they are integrated into the site and you're designing with that community values piece in mind, that they're better taken care of and they're better maintained. This one actually, this is Morse Park in Lakewood, and this is a before picture here. Isn't that a great before and after shot of an area of a public park? And this was one where one of the residents across the street contacted Lakewood and said, I have this idea where we could put in some water quality in this park and really make it an amenity.
And isn't that a great connection for the community now to have a part in reaching out to their local government and saying, can we do something better here? And they really value that. So I want to end with also a couple content highlights and things that you can look forward to seeing outside of this change in structure and focus on understanding the intent behind components and the intent behind design decisions. So you will see, and these are all things that stakeholders requested, a more solid connection between how can we really ensure that we're meeting the MS4 design standard, and there's information on every fact sheet for that now. We greatly expanded the manufactured treatment device guidance. So previously we had one fact sheet that was lumped in with just everything that was underground. And now we have two fact sheets that have some really good detailed information and design procedure to step through. We have additional level spreader guidance. It's not just limited to grass buffers, but you can use level spreaders anytime you want to move water from one place to another, right? You can use a level spreader to bring in runoff into your SEM. Maybe it's bioretention, and that allows you to really spread the water out and have the vegetation benefit from that. You can use a level spreader as a stream outfall, which is something that we've done at the district. We are in discussion on an alternative to the micropool for a certain scale EDB. And we are also working through changes to the bioretention media in an effort to provide better support for the vegetation in these basins. And this is not actually part of chapter 4, but the discussion around MTDs really brought about a need for being able to calculate the peak flow for the frequency event that we designed to, the WQCV. What is the peak flow, so that we can size conveyance elements, size inlets, and so we can, so we have what we need to design manufactured treatment devices. This is our schedule again and where we are now, and you can look forward to a published chapter in 2022. And I will stick around for questions at the end of the session.
Thank you so much, Holly. I appreciate that great overview. We did have one quick question on how to supplement the areas for the bioretention ponds during drought.
You know, I don't know if we have guidance on that in the chapter, but we do recommend that you have that these are installed with irrigation at a minimum to get them established. There is some more discussion on vegetation. But we have found that in Colorado, you really need irrigation to get them established. And then it's a good time to consider whether or not you need to continue that, or if you can stop at that iris site that we showed you. We needed just 1 year for establishment, and it is solidly green. There are a number of local governments that supplement just with trucked in water. But we found that in Colorado, you really need irrigation to at least get it established.
Thank you. And a lot of that goes with plant selection as well, and choosing native plants that are adapted to the area instead of plants that need additional water.
Absolutely.
Yes, so thank you for that. And now I would like to invite Dr. Sybil Charbel to take over our next session and talk to us more about what is happening at the Spur campus for CSU.
Well, thank you, Jessica, and thanks for having me. So I'll be talking a little bit about kind of broadly green infrastructure and some of the things that are planned for the Spur campus where we have a water technology accelerator. This is an image that I really love from National Geographic, and this is kind of showing the city of the future and these kind of urban hubs and a vision for how we would design cities in the future. And you already saw a lot of green infrastructure, great green infrastructure examples from Holly in the last presentation. And looking at this kind of image of this highly urbanized area, what we see here is a lot of green infrastructure integrated into the area and kind of compact, tall building areas, but with green infrastructure in the middle of those that provide urban livability and improve hydrology and stormwater management as well. So kind of looking through here, we see green roofs and things like rain gardens and really a water sensitive urban design where the water management is very much integrated into the urban design. And this includes potentially some water recycling projects as well. Holly had so many great pictures of green infrastructure that I don't know that I need to show more, but this is just an example of rain gardens. And then green roofs are where we can grow plants and potentially even crops on top of roofs. And this provides a lot of benefits in terms of cooling as well, or building cooling, as well as providing some stormwater management benefits. And we'll hear a lot more from Jennifer later about those. This is a great example I like to show of a stormwater project that I did not know existed until I had a talk from, just a second here. So until I saw a talk from Washington, DC Parks Department, where they showed that actually under the Washington Mall in Washington, DC is this large storage tank, and stormwater that's collected in that area is diverted to this storage tank and then treated by ultraviolet and some ultraviolet light and some filters and then used for irrigation on the park. So this is a nice example of how we can capture and use stormwater, and that's certainly a component of green infrastructure. Okay, so when we're talking about this, we need to kind of understand fit for purpose water. And I really define fit for purpose water as appropriate treatment of water based on the source water and end use combination. So I think about it as right water for the right use. So we don't need to necessarily treat all water to potable level standards. And we have many different kinds of source waters that we can use. Black water, laundry water, storm water, roof runoff, gray water. All of these sources are potentially beneficial and really require different levels of treatment depending on the types of end use that they may be used for. In addition, there's lots of different scales that these kinds of projects can be implemented at. So we can think about single residence scale projects. We can think about building scale projects where you have water recycling within a building, maybe gray water or even black water. And then we have the centralized scale, and these apply to stormwater as well. We can think about residential roof runoff. We can think of building runoff and maybe collecting foundation water. And then at the larger scale, we can think about collecting regional scale stormwater and treating that and distributing it back into distribution systems for potable or non-potable uses. So there's all these, we've seen several examples of these kinds of projects and green infrastructure, and Holly had a lot of really great examples of green infrastructure and also talked about some of the research ongoing with those. But we still have a lot of questions remaining about fit for purpose water systems and green infrastructure, and particularly as it relates to stormwater capture and use projects. So how can on-site water treatment technology efficiency and reliability be improved? What is the impact of green infrastructure on local hydrology and water quality? And Holly talked a lot about the different measurements that are being taken on different types of systems. And how can green infrastructure technologies be improved for better performance? So we still have a lot of questions about these kinds of practices that need to be answered. And we're really looking toward the Western Spur campus, National Western Center Spur campus, to answer some of these questions and be able to conduct some really innovative research on fit for purpose water systems, as well as green infrastructure and how that can all integrate into urban environments. So there's a lot going on in this picture, but this is a plan for the Water Innovation Center at the Spur campus. And I'm going to kind of break through some of these different components here. So starting here, there's going to be a lot of test plots in this is called the backyard of the water building center. And here there'll be bioswales and green infrastructure that can infiltrate and absorb stormwater runoff. And part of the problem that we've had on data collection on green infrastructure and stormwater control measures is that it's hard to get enough data on the influent and effluent quality and what's happening in the whole hydrologic system in terms of evaporation, infiltration, and volume reduction. And in this backyard, we'll be setting up the right infrastructure to be able to test these green infrastructure and stormwater control measure technologies so that we can really understand what's going on. And so this will provide a space for actual visible green infrastructure technologies where we can really get the measurements that are needed to move things forward. On site, we also have gray water reuse that will be implemented in this building. So gray water will be collected from some of the showers and sinks in the building, sent down to this treatment area. This is called the high bay space, where we're going to have this lab where we have multiple sources of water coming into one system where we can test different types of technologies for water treatment for fit for purpose use. So gray water reuse will actually be implemented in the building, and we can also do research on that as well. Vegetated roof, which again, Jennifer will be talking about this a little bit later. So we have a green roof on the building, and even potentially some collection of roof runoff to provide water for that, which we'll hear from Andrew as well on some of the plans for roof runoff on the site. And then stormwater research. So if we just look at this backyard area, the stormwater collected on site there is not necessarily representative of what we would think of as typical urban stormwater that would be running off from roads and parking lots and places where there are more vehicles and other sources of contaminants. So we have actually collection of stormwater that'll be diverted, that is collected from an urban source, an urban drainage area, will be diverted over into this area, stored, and then made available again in this high bay laboratory space where we can really test those different types of water sources. So this is really serving as an innovation hub to test different technologies for fit for purpose water and stormwater management. Okay, so this laboratory really offers a first of a kind laboratory for testing of technologies for multiple water sources. This is really an amazing opportunity to have all of these different water sources coming into one central location where we can test different types of treatment technologies. And so we can see that perhaps we can do building scale water reuse systems. This picture on the bottom right, I actually thought I had a picture of this earlier in my presentation, but somehow that got skipped. This is from Battery Park in New York. And this is where they recycle wastewater in that building to flush toilets in the building. So it's kind of a basement kind of treatment system And we would be testing a lot of different technologies like this at the Water Technology Accelerator Lab. And this, again, we have all of these different source waters like stormwater, roof runoff, gray water, recycled municipal wastewater will be accessible. And then we also have space to truck in industrial sources of water and set up treatment systems for those there as well. So really nice hub to really be able to test all these different water sources and have all the infrastructure in place. It'll be kind of like a plug and play system where technology innovators could come in and bring in their technologies that they want to test, and we have all of those different water sources coming to one space where we can run experiments and evaluate the performance and improve technologies for better performance, and particularly looking at reliability of those different kinds of treatment systems. The great thing is also, we also have this in situ and laboratory testing and performance of green infrastructure. So we have some of the green infrastructure that's on site, actually in place in the backyard of the hydro building. But then we also will have capacity, again, in this laboratory where we'll have roof runoff or urban stormwater or stormwater that's collected from the backyard site, that we can test different types of technologies at the laboratory scale and really foster some of the innovations to further develop those technologies, make them more efficient, potentially improve pollutant removal, and improve hydrologic benefits as well. So we can test at the smaller, more laboratory scale, and also have these kind of intensive places where we can test green infrastructure systems that are in place. So just to kind of summarize, this is a really exciting opportunity to have all of these different water sources in place and all of the infrastructure where we can really have this hub to move forward one water concepts and fit for purpose water. I do want to mention, as we kind of think about stormwater control measures and the benefits and how we make decisions related to stormwater control measures. We have a classic tool that's available on classic.erams.com. This is a web-based tool that provides outputs related to performance of green infrastructure, stormwater control measures. LCC is life cycle cost, and then triple bottom line, or TBL, benefits as well. Classic provides this kind of 3 sets of outputs, and the idea is that then a user would be able to make use of this information from these 3 different types of outputs to inform better decisions that consider benefits, performance, and cost associated with different stormwater control measures. In a later session today, Mazdak Arabi will be talking, and he'll give a little bit more example, I think, about Classic and some of the tools that we've been developing at CSU that address urban water systems and stormwater control measures. So a large contribution of the Classic tool is that it does provide a high-level assessment of stormwater control measure co-benefits. And this is kind of based on the integrated urban water management sustainability kind of perspective, where we have these different indicators that we look at in terms of trying to make integrated or trying to make sustainable urban water management systems. So we have flood protection, where we look at things like social impacts from flood controls, cost of flooding damage is considered, species diversity, addition of green space to support additional habitat, green jobs and public education and outreach. Thermal comfort is a benefit that we think about with these different green infrastructure technologies. And then there's, of course, the water supply reliability associated with using stormwater or roof runoff as a potential source of water to supplement our traditional supplies. So we have a lot of these different kinds of benefits, and the Classic tool does provide scores. And so a user would set up scenarios of different stormwater control measures after they select an area and get outputs related to these different indicators. Okay, so OneWater technologies require further research and demonstration. We still need to collect more data on performance of both green infrastructure systems and on-site water recycling systems and municipal scale water recycling as well. And these innovative concepts in OneWater design will be actually implemented at the Spur campus. So it'll provide a really nice demonstration space for implementing OneWater concepts, but also very important, it's a water technology accelerator at Spur will serve as this platform to enable advancement and commercialization of OneWater technologies. And no space like this exists to date where you have access to real sources of water of all of these different types and can conduct these kind of testing in this kind of plug and play way. So we're really excited about the opportunities that will come from these the space at Spur, and looking forward to construction. So thank you very much, and I'll be happy to take questions, but at the end, I think we may have some time for questions also now.
Yes, great. Thank you very much, Sybil. We do actually have a question that came in, and since we have a few minutes, want to go ahead and ask. Let's see. Do you know if there are any water quality testing protocols proposed for use at the testing center? It would be great if testing protocols were similar to already tested SCMs, so results can be compared easily.
Yeah, well, Holly could take this as well. She's involved in the Spur campus development, and obviously talked about a lot of the different research activities that are happening around the Denver metro area for collection of data on these different stormwater control measures. So this will be a very much coordinated effort. Andrew Earls, who will also be talking next from Right Water Engineers, is also engaged on the project. So we have this consortium of multiple partners that are working at the Spur campus to design this space in a way that the results that we get from research and demonstration projects are beneficial to the stakeholders that are engaged in these processes. So we definitely have a lot of coordination. Jocelyn Hiddle, who is at CSU, kind of spurring the efforts to coordinate the development of the Spur campus, has been really great at getting all these different partners together to have a integrated design and concept for this center.
Wonderful. I think we have time for one more question. Another question was, to get good information, you usually have to have a multi-year testing program. How can data and results be accelerated so good techniques and facilities can be utilized sooner?
Yeah, so that is a large problem, particularly with stormwater, when we're relying on getting events to come that we're kind of always waiting on weather to be able to collect data. And it does take a long time to collect data on particularly the stormwater systems. And the one thing with that I'd say that we can kind of accelerate things is through some of the activities in our laboratory space. So the laboratory is down here, and we have all these different storage tanks. So we will be storing stormwater, for example, that we collect and have long-term storage of that we can kind of quickly test different technologies at the laboratory scale. Hypothetically, you could potentially even feed some of the stormwater control measures on site with those, or maybe there's even potential to add new ones. So that is one way that we're kind of looking to advance technology development, is having a consistent, reliable supply of these source waters to feed into these systems. This is pretty large scale. We're talking about scales on the order. We're planning on experiments that could be supported that we provide hundreds up to thousands of gallons of water per day to these test systems. So that I really see this innovation center as being a place where we have this consistent, reliable source of high flow waters to advance these technologies.
Wonderful. Thank you very much. We do have one additional question, but we will wait for that one till the Q&A. So thank you
Great.
once again, Dr. Charvel,
Thank
for
you.
your fantastic presentation on what will be coming up in the available research that we'll be working with soon. I'd like to now introduce Andrew Earls. He's the Vice President of Water Resources for Wright Water Engineers and has been working with Holly and with Sybil as well on multiple projects. Thank you for being here. Andrew.
Well, good afternoon, everybody. I'm just putting myself into presentation mode. And I'll tell you, you guys are going to think my graphics were put together by a second grader after the presentations that Holly and Sybil just gave. And I really thought those were great. And I'm going to really build on what both of them have talked about. And, you know, I wanted to start out before I kind of get into the details, though, by saying that I'm really just a spokesman here. You know, this is a huge project, and I'm going to talk about the rainwater harvesting demonstration that we've done, which is just one piece of it. But even with that one piece of it, you know, it has been a huge team effort, and Jocelyn Hiddle has really led the charge from CSU, Spur, and Bao Tua from the flood district has been spurring us along as well. And we've gotten a lot of great input from Chris Krager and Ryan Taylor at Muller Engineering. So although I'm the one presenting today, this represents work that a lot of others have done, and I'm just the lucky guy who gets to present it. But anyway, it is great to be here today, and I'm excited about this project. And you know, this is, like I said, not quite as good of a graphic as Sybil just had, but really, you know, this is a site that has multiple stormwater systems. And the part that I'm going to talk about is what's shown in red on this figure, which is the roof collection and the rainwater harvesting tank. But that's just a tiny part of the overall system. And really, the backyard has tremendous opportunities. You know, there are underground tanks. This pink line that you see on the figure, that actually diverts runoff from Betty Cram Drive. So real live urban runoff into a tank that can, you know, then be piped in to test in the high bay lab that Sybil will be running, or it can be run into some test plots that Denver is planning on the site too. You know, there also are opportunities here that Jennifer Busolo, I believe, will talk about in one of the next presentations about the green roof. You know, the high bay I already mentioned. There also are these bioswales, which you can see as kind of the bluer features with the arrows, and we can monitor those as well, not only for you know, live stormwater runoff events, but if we wanted to release water from a tank down some of those bioswales to test runoff reduction, that will be an option too. So in short, you know, there really are multiple systems here, and also including, as Sybil mentioned, imported industrial water or potable water if they want to use testing with that. And really, by having all of these multiple systems all tied together in an area that's run by a university that has a lot of expertise in this area, really makes this truly a stormwater research paradise. And I am really excited about the data that can be collected here. You know, in addition to the work we've been doing on the rainwater harvesting tank, we've currently been working with the design team to figure out what type of monitoring equipment needs to be put in place. You know, just for the rainwater harvesting alone, which you can see zoomed in here a little bit, you know, we're going to get into water rights. So we need to know how much water is stored in this tank each day, how much it changes, and how much water we have to augment. So that alone is one water measurement area. But we also want to be able to measure flows that overtop the tank and go into the bioswale. We want to be able to measure flows that come off of the roof and enter the bioswale. And we want to be able to measure the outflows from the bioswale. And really, from a hydrologic standpoint, you know, there are kind of these smaller objectives on the site, which could be testing in the bioswale or testing in the lab or testing in test beds. But at the end of the day, one of the things that we would really like to do is to come up with a hydrologic balance for the whole site. So we can have testing data on the ground for how do each of these individual measures function. And then by measuring the outflows from the site and collecting rainfall data, we can also answer the question of how do all these measures work in concert with one another and how much runoff is reduced from frequently occurring storms coming off the site. And just knowing what these plans are, I'm really excited to see those results, because I think that we're really going to see some significant runoff reduction, even, in storms up to and above the water quality capture volume on this site, because there are just so many different layers of stormwater control measures. So to get into some of the specifics of rainwater harvesting, which is what we've really been focused on, we're taking the roof area, or at least a portion of the roof area, and we're going to drain it into a tank that's going to sit outside near the high bay laboratory. And that water will be available for testing in the high bay laboratory. That water will also be used for irrigating a test demonstration area for some native plantings to show that we can use this harvested water to grow native vegetation on the site as well. So really what we had to do for the tank, it was a really interesting problem, because there are multiple variables that we had to analyze and a lot of moving targets. We first needed to figure out the drainage area and how much of the roof we harvested. And that, of course, included evaluating how much water is evapotranspired by the green roof and other features. We also had to figure out the demands, and Sybil helped us a lot with figuring out how much water might be used in the laboratory. And we got a lot of great input from horticulturalists at CSU and from Denver Water on the irrigation demands for the demonstration area, because natives really require a much less frequent watering schedule, especially once they're established. And but in dry times, they do need some supplemental water, and that's what we'll provide. And then on the irrigation side, we had to dial in on what are the evapotranspiration demands. And of course, that was kind of a horse and cart situation, because a lot of the plans were still developing, and Jennifer Busolo provided a lot of great information on that helped us out. The watering schedule, again, I'm not an irrigation specialist, so Denver Water and CSU folks helped a lot on that. And then, of course, having some contingency plans for when we hit really, really extreme droughts and you might have to apply some supplemental water. If we get into a situation like that, we can add potable water to the tank and irrigate using the same irrigation system if needed. And we'll just have to account for that a little differently in the way we're doing our water rights, since it would be potable water. But the way that we chose to answer all these questions was to use a continuous simulation using the stormwater management model. And we've been doing this on a fair number of green infrastructure projects lately, including Oak Gulch down in Parker, which is a project we've worked on with Muller and with the flood district and the town of Parker, as well as the developer. And there's some real benefits from running continuous swim simulations as opposed to, modeling a 0.6-inch storm or modeling a 2-year storm. I mean, when we do design-based storms, those are valuable for sizing pipes and things. But when we want to really look at the benefits of green infrastructure, we can measure things on the time scale or model things on the time scale of a design storm, things like peak flow rate, runoff volume, and other things, and we can quantify those, and that's wonderful. But some of the best benefits from green infrastructure come from evapotranspiration, and that's just not something that you can model on the scale of an event. And so it's really about what happens to that water in between the rainfall events. And that's what the continuous simulation gives you the ability to do. And, you can build in about as much sophistication as you need to. And our real approach here, because the design plans were still being developed as we were doing this, was to, do an iterative process with the design team. And we started out with a very simple model. And then as the design plans developed, we built in additional pipes, we built in storage nodes to represent tanks, and we built the complexity in as the design developed. And I think we have a very good and accurate swim model to be able to do this. And, there are multiple reasons that we did this. And the ones that I listed on the previous slide, sizing the tank, figuring out how much roof area we need, figuring out how much irrigation are really good examples of how we use that. The other way that we used it, and the reason that evapotranspiration was so important in this case, is that we needed to be able to quantify our depletions for water rights. And, this is just one of the scenarios that we're showing here, one of our multiple scenarios, and we ran dozens of these. For R1 and R2 are different roof areas. So we evaluated on this graph, how much percentage of the ideal annual usage that we want are we going to be able to achieve on one axis versus the percent of the backyard irrigated. And you can see that really there is we honed in kind of on a sweet spot of irrigating about 1 to 2% of the backyard area with the tank sizes that we were evaluating. And that actually ends up being a nice size demonstration plot, which is really the main objective here. It's not to water the whole site, but it's to show people that it can be done and to develop an educational demonstration to encourage other people to consider doing that on their own lots or their own developments. So I did mention that one of the most important reasons that we did all of this modeling was for water rights. And, you know, I think a lot of people on this phone, having practiced in Colorado, probably are familiar with these, but probably like me and most drainage focused engineers, we are not experts in this. And, you know, we involved a couple of water rights experts at our firm. A guy named Mike Glade has provided a lot of excellent information. We also have been working with a water rights attorney, Kristen Mosley, at the Porzak law firm. And our goal is to quantify, you know, if we take this water that runs off the roof and then Sybil goes and uses it in the lab, and ultimately it goes down a drain to the wastewater treatment plant, you know, that is water that is not making it to the river that otherwise would have. And so the way that this is looked at from a water rights standpoint, even when you're basically creating new water by creating impervious surfaces, is that water technically belongs to downstream water users. And so in order to legally harvest the water, we need to replace the depleted water and as we use it, and we have to monitor how much of it we use to replace it. And for the short term, we're working with Kristen to develop a substitute water supply plan, which is kind of a temporary permit to allow you to harvest the water, with the goal of leading into an augmentation plan, which would be a permanent water right to allow that and to have established augmentation. And I want to acknowledge two things here. Number one, you know, Holly Pisa and a project that she did very similar to this, harvesting water at the Green School, has reduced our brain damage tremendously. It's so great to actually have an example in the metro area where this has actually been done. And Holly has really provided a good template and a model for what we're doing here. And then secondly, I'd like to acknowledge Denver Water, because they have really been on so many phone calls in this discussion. They've been very supportive of this idea. And at the end of the day, they're going to be the ones that help with this augmentation plan. And so once we quantify all of this and we kind of maximize it all out, and we look at, you know, a dry year is the most critical situation for sustaining the irrigation, but a wet year is the most critical year for depletions, because a wet year is when we can actually harvest the most water. And so we've come up with an estimate that we will need to replace about 2 acre-feet of water in a worst case year. That has a little bit of kind of uncertainty built into it. And some years we may be only replacing on the order of an acre-foot. But I think that we are now in a position where the design's moving to a point where we are going to be moving ahead with this substitute water supply plan very soon. And then that will lead into the augmentation plan. And so really, all of this that I've been talking about really leads to a lot of really cool monitoring and research at the hydro building. And we've been working with the team to figure out, you know, what types of equipment do you use? If we're going to measure the water level in the tank, you know, are we going to use a pressure transducer in the tank? Or, you know, does the tank have enough headspace in it that we can use an ultrasonic meter that would probably be lower maintenance costs because it's not submerged all the time? So we're working through a lot of those, but the types of monitoring that I think you're going to see coming out of this site, and Sybil has already mentioned a lot of these. You know, you have the water rights accounting, which is demonstrating something in and of itself. It's how much water do we have to use to sustain this irrigation area. We can also monitor the vegetation health of what we're irrigating with the harvested water. You know, they'll have a rain gauge and a climate station, so we'll be collecting really valuable climate data there that can feed into modeling and data collection to do a site-wide hydrologic balance. I think Jennifer has some plans to monitor the green roof outflows, and we're going to monitor those bioswales to see how much runoff reduction we get. We also may be able to even do some water quality sampling there. Denver has a few test beds that they're planning for bioretention testing. I think the main plan for those is to use harvested water from Betty Cram Drive to put real dirty urban runoff actually through those cells. And then of course you have the laboratory testing that Sybil will do. So really, I'm excited to do this overall site water balance, because really what we have here is something that is really advocated in volume 3, and it really embraces that 4-step approach that Holly was talking about. And if we can look at the individual elements of this treatment train approach and figure out how they perform individually, but also look and take a step back and say, how do they all perform together to reduce runoff and improve water quality? It's just going to be really cool research that comes out of this site. And I think the other thing is that there are a lot of opportunities for adaptive management to see how vegetation does under different conditions. And, you know, plants, I mean, it's not cheap to replace them, but if you wanted to plant vegetation in one area that receives stormwater and monitor it and see how it does, and then tear it out and put in some other type of vegetation for a few years, that's the kind of thing you could do on a site like this with the plumbing that's being built into it. And in the last 5 minutes that I have here, Jessica had mentioned she wanted me to talk about the water harvesting, of course, but I also wanted to spend just a few minutes talking about some other areas of research and innovation that I'm aware of in Colorado. And Holly has already touched on a lot of these, but the Flood District has really been doing great research with Mueller engineering on healthy topsoil and healthy soils for stormwater control measures. And as she mentioned, I think in the update of chapter 4 of volume 3, you will see a lot more of that, but there is excellent topsoil management guidance. And the thing that Jim Woolleman's really into are all the critters that live in the soil, you know, from earthworms to the fungi that live there. And all of those things really create a healthy living soil that does amazing things for water quality. And so that is definitely an area of ongoing research. And I think Holly also mentioned this idea of receiving pervious areas, which is, you know, another term for buffers and swales, but it's really intended to think more broadly about receiving pervious areas that may not be as regularly shaped as buffers or swales. And what you're seeing in this photo on this slide is actually up in Boulder, North Boulder, where you have this really nice kind of grass buffer area. It's not super long, but, you know, it gives an opportunity for these downspouts to infiltrate before it gets to that inlet that you can see on the left-hand side of the photo. So that is another area that I think is going to be coming out and being put into practice more. And then, of course, runoff reduction for SCMs is a topic we're all interested in. But I think one thing that's a big question is that I know I have and others on this meeting do is, if you have SCMs that have underdrain, aren't you still getting some runoff reduction from the wetting and drying of the media? I can pretty much guarantee you do, and there's some data that shows that, but I think there's some opportunities to collect more data in Colorado to really get an idea for how much credit you know, people might be able to get for runoff reduction for bioretention facilities or swales that have underdrains that still provide, you know, a significant level of runoff reduction, perhaps not to the level of the runoff reduction standard in the MS4 permit, but still a significant amount. And then the last two items I want to talk about, and I have two more slides on them, is high functioning, low maintenance streams, which is something that I think most people on this meeting are familiar with, that the Flood District is working on, and also the idea of using stream restoration as a BMP. And, you know, this is a photo of Cherry Creek, two photos of Cherry Creek from a similar location. And if you look at this building on the left-hand side, or on the right-hand side in the 2017 photo, that's the same building on the very left-hand side in the 2021 photo. And I didn't get the angle exactly right when we had these photos to compare, but you get the idea. You know, this channel was incised by 5-10 feet or more. And really Mueller Engineering with the Flood District and the City and County of Denver went in and have developed a really beautiful stream through there that's going to be low maintenance for the long term. And in the process, they have significantly reduced the amount of sediment that's exported for this reach. This reach is right below or not too far below Cherry Creek Reservoir. So it is just with that hungry water eroded. And, you know, we wrote a paper on this actually that you can look up in ASCE, but we evaluated, and Brick Zivkovich of the Flood District actually helped with this, you know, how much would this stabilization reduce in terms of sediment, phosphorus, and nitrogen going downstream in each year, in an annual year. And really what we came up with some detailed analysis that has now been published in a peer-reviewed article is that this, you know, from Iliff to Quebec Street, you know, you're reducing about 1,100 tons per year of sediment through this stream restoration project. And it would take a whole lot of EDBs to come to that same level of sediment reduction. So I think that that's a really interesting topic along with the others I mentioned. And now that I'm out of time, I'll give my final acknowledgments to the CSU SPUR team. We at Wrightwater feel really fortunate to be involved in this project, along with all of these other great experts. Of course, the Mile High Flood District and Denver Water and Muller Engineering. And we couldn't really be doing any of this work without all of those people and others that have been involved. So thank you very much. That's the end of my presentation.
Thank you, Andrew. And what already we're seeing trending through all of the presentations is how critical partnerships are and how many different efforts are going into making sure that we have the right research, the right tools that we need to be able to make green infrastructure effective as we implement it moving forward. So thank you very much for your work. And I am looking forward to introducing Dr. Jennifer Busolo, who will give us a more in-depth discussion of green roofs. Jennifer?
Thank you so much, Jessica. I really appreciate it. I hope you can all see my screen now.
Yes, we can. Thank you.
Wonderful. Thank you. So I'm a professor of horticulture in the Department of Horticulture and Landscape Architecture at CSU. I just want to be clear, I'm not a stormwater engineer. I do love talking to stormwater engineers. I've been doing it for at least 15 years professionally. And so it's always a delight to interact with all of you. And I'll mention, several familiar names as we go along. I've been able to present at CASPM and other places as well, and work closely with Holly at Mile High Flood District. So I'm going to talk about green roofs. I've spent the last 15 years on this topic of my career. And here's a picture of what should be the most famous green roof in Denver. This is the Children's Garden at the Denver Botanic Gardens. It's where one of my graduate students is doing research. He's actually finished it up. He has moved on to another position in their organization, but he took this picture and we've done some really landmark work on it. And so this is a full acre green roof. Some of it's hardscapes, but a full acre green roof. And I hear all the time and often from designers and engineers that green roofs don't work in Colorado. And that's just simply not true. It has everything to do with design. So I'll try to focus on the key aspects that are related to successful green roof implementation in our state, because it is more challenging than, say, the East Coast. But if we know our environment and we know our plants, we can have successful green roofs as well. So my journey with green roofs started in 2006 on the EPA green roof in downtown Denver, just really across the 16th Street Mall from the Union Station. And so that's a half-acre green roof. I actually no longer work on that project. The funding for that sunsetted, and the EPA has since actually scaled down so much they don't have access to this rooftop anymore. But we have published a lot of work on this. In fact, in one of the listening sessions that Mile High Flood District presented over the spring, I sort of flooded everyone with the amount of data that we have published on this work. It even has taken me to really be passionate about using Colorado native plants. Here's a book I'm co-author on, Common Southwestern Native Plants, and I'm currently writing or updating the Trees and Shrubs of Colorado, both originally by my late mentor, Jack Carter. But I'm not just interested in native plants, I'm also quite interested in growing food on rooftops, specifically combining solar panels and food production, and that we call rooftop agrivoltaics. I have a TED Talk on it if you're interested. And that's literally growing food under solar panels on top of buildings. We just spent a significant amount of money putting in an emulated green roof, a simulated green roof system on the ground at the CSU Foothills campus in Fort Collins, so that we can use this space to evaluate a whole bunch of native plants, but also food crops, and even a very drought tolerant sedum species on green roofs under solar panels, because we found during my PhD work how synergistic those systems can be. So the reality that a lot of urban dwellers have is an ugly rooftop when it doesn't have to be like that. And that's still the #1 reason green roofs are installed worldwide. It has to do with aesthetics. There's more compelling reasons too, but that's still the #1 reason. The #2 reason is for managing stormwater, both quantity and quality. And so it doesn't have to be a massive sensational green roof like this one that's at the California Academy of Sciences. You can start small and understand this system because it is a unique system, and it sort of gets to the point that Holly was making earlier about just making sure we scale. Of course, you're not going to capture much stormwater on a birdhouse green roof, but hopefully that sort of illustrates that there's a whole bunch of scales that green roofs can be applied at. So I was lucky to help write the original green roof section for volume 3. And I've been working with Mile High Flood District and Right Water to rewrite that section to build in sort of all the updates that have happened since 2010 on the green roof front. Worldwide, there is tremendous work going on, including a whole bunch of products that will capture more than the 1 inch that's typical in a 4-inch deep system as far as quantities. And of course, we have to be careful about that. I saw a question about water law. The really good news is when our water authority in the state put out a memo on green roofs, essentially they said as long as you're not capturing water outside of the roof zone, you are not in conflict with downstream water rights. So we are technically in a really good place to be able to do as much green roof implementation as we possibly can. So there's a whole bunch of things going on in green roofs, and I've been asked to talk about the topic of the green roof / green building ordinance so much that I thought this might be a good crowd to talk to, since many of you work in and around municipalities so much. This is technically only the city and county of Denver, but I've heard murmurings from other municipalities that similar policy might be coming down the line. And because of this policy that was enacted now, it's 3-4 years ago, there are a number of green roofs being proposed that are fairly high profile. Here's a design by, I believe it's Triba architects at Fox Square, so where the old Denver Post distribution facility is on the south side of Denver is where this one's being proposed. So the history of this ordinance is in 2017, it was passed in the general election to have a Denver Green Roof Initiated Ordinance 300. I was the technical advisor on that. To walk a careful line, being of course employed at a state institution, but I could advise on that topic since that's my specialty area. So it passed apparently by a landslide, 10%, that's not a landslide to a scientist. And it was based on policies that have happened elsewhere, including Toronto, Canada. There's a whole bunch of legislation actually that's gone on worldwide related to green roofs specifically, although there's a leaning more towards green infrastructure in general rather than just green roofs. And in part because of that, green roofs aren't the only solution. And yes, I said that as a green roof expert. They ended up, the city called a task force to sort of rewrite the ordinance back in 2018. Of course, I was on that. And we rewrote it. And in 2019, it was passed by City Council as the Denver Green Building Ordinance. I sit on the Technical Advisory Committee. I have since its initiation. We had a meeting this morning. And there's more changes coming. So you don't have to memorize the next couple of slides, but these next couple of slides sort of summarize what the Green Building Ordinance is. And the reason, beyond just informing you all about this, that I want to mention it has to do with there are ways for site developers, building owners, to get sort of extra credit for having especially green roofs on their properties. Oh, I forgot, I was going to mention also green roofs and water. I saw that question come up about native plants. That's a great point. Native plants, yes, depend on our native water, but they usually have to get established as well, and they actually look much better if there is at least a minimal amount of supplemental water, whether it's on a green roof or on the ground. So when this ordinance passed, Denver Water got on that task force in 2018, and day one, they were concerned about potable water use and increasing potable water use on green roofs in urban spaces. And if there is, we sort of estimated about 5,000 acres of low slope or shallow, or I'm sorry, fairly flat looking rooftops that are eligible for this ordinance. They were nervous that that many acres of green roofs would end up increasing demand on water. So what we did was, and I can't actually say I contributed except sharing irrigation data from some of my EPA work, and they ran an evaluation, and they made a couple of assumptions that it was about 1,000 acres, because 20% of the rooftops was the original estimate in the Green Roof Ordinance. About 20% of all rooftops would need to be greened in order to make high impact for all the environmental benefits. I sort of skipped over all those environmental benefits, expecting maybe most of you knew that. We made some assumptions that 95% of those green roofs were either succulents or native species, and that 5% were higher water use, so turf and agriculture. And when they came out with the results, I was jumping for joy, but I sort of knew what the results would be, is that it only increased water use by 1.15% in the city, in the service area that would be affected by Denver Water. So they said, unless you are getting up to that 7-8% for any one industry, they are not interested in really engaging that faction. It's just not enough of an impact. So that was tremendous news, because we really want to focus on low water green roofs that ideally will be low water, so that as the rooftop dries out, it can capture water during a next event. The one thing I will also mention, and it's not something that comes on the radar of a lot of designers and engineers, is that in our environment, we need some supplemental winter watering. And so it's a very minimal amount, literally just to keep those plant roots from desiccating over the winter. So here are those couple of slides I thought I would mention very briefly. So the Green Building Ordinance is broken into two segments. It's new buildings and existing buildings. And this one, for some reason, this is for new buildings. Nope, yep, new buildings. This is for new buildings. There's a number of options for compliance. It's not just green roofs anymore, but green roofs are an option. So is green space on the ground. And if for some reason it's in an ultra urban space, you can pay for off-site. Then there are other options that don't necessarily include all that much as far as green, but get to some of the other environmental benefits. So green plus solar or energy efficiency, solar or energy efficiency by themselves, and certifications, LEED certifications. There's modifications coming down the line though. It still has to be passed by city council, but some of these are going to change. And for existing buildings, there's actually a few fewer options, only because it doesn't necessarily, all of these options don't necessarily equally apply. So very parallel though with green on-site or off-site, green roofs, solar, and certification and energy programs. The one thing to keep in mind is there's more policy coming down the line. It should be out by end of this year. Through Energize Denver, it's a new energy policy that will influence this somewhat, but not terribly directly if you're only working on the green aspects. So I have, as mentioned earlier, a bunch of research coming up at the CSU Spur campus. This is a very old graphic, but I really liked it because it showed the two buildings that I'll be doing green roof research on. One of them's Terra and one of them's Hydro. And so Hydro you've heard a lot about today. This is a little bit more updated picture of what the front of Hydro is going to look like. So I'll have several different research projects. I'm going to do food production and irrigation. We want to minimize the drops per crop it takes to get high yield up on a green roof. Not that it's going to feed the world, but that we can have a little bit more food security and resiliency in our cities by using some unused space. Native plants and pollinators. This is actually following up on the Denver Botanic Gardens research. I have the next graduate student already hired to work on that aspect. And then over on the Hydro building, those first two are going to be on the Terra building green roof. I have a solar panel and green roof, so the rooftop agrivoltaics work, and the stormwater capture. So I have a graduate student who's on this, just started and is on this call that will be working on that project. She has her undergrad in engineering, and so that will be actually funded, already is funded by, that work is funded by Mile High Flood District. And actually CASPM also gave us a grant as well for materials. So I hope to also get some additional funding through the green roof industry, working those angles in development all the time. So a couple of examples, pretty pictures are always nice. Here is the first green roof at the Denver Botanic Gardens, only about 1,000 square feet. We've written a couple of papers on that if you're looking for species survivability, and only at about 7 inches of irrigation a year. So it's tremendously low, especially when you think about how turf grass, a drought tolerant turf grass is 1 inch a week over the growing season. Most are more like 1.5 inches to 2 inches of irrigation a week. So this is a very minimal amount of irrigation to keep plants living on rooftops. And here is my graduate student, Michael, collecting nectar and watching pollinators. Is what we're finding in his research is that native plants not only are drought tolerant and provide benefits to pollinators, but on green roofs compared to at grade, they're actually flowering earlier. We think a lot of that has to do with root zone temperature being higher on a green roof, more abundantly, and they're even having higher sucrose content nectar. So all of those items have not been published yet, but they are in the works. A whole bunch of excellent examples out there from the foothills. This one's up near Netherland to right downtown. So Community College of Denver, all native plants on both of these green roofs. This is what it looks like during the winter. My buddy Andy Creeth of Green Roofs of Colorado installed both of those. And I have, like I mentioned, some key publications I thought I would offer up in case you're interested. You can contact me. I'll give you my email address for any of these. A recent book came out called Eco-Regional Green Roofs that I'm co-author on a couple of chapters of. It's going to be a great resource, tons of species lists, tons of case studies of excellent green roofs, not just in Colorado, all over the western half of the US. We also have a great review paper, a Green Roof Research in North America, Recent History and Future Strategies from just last year. Also my book I had mentioned, and then some of the initial work on integrating solar panels and green roofs as well. So I'll leave this slide up here. There's my email address, jennifer.busolo@colostate.edu, and several excellent books, including another one I didn't put on here, but I happen to have at my desk called Small Scale Green Roofs, in case that's of interest. Small green roofs. There's a whole bunch of excellent books out there on green roofs. So I don't know, Jessica, if there's time for questions or not, but.
Thank you so much, Dr. Busolo. learning more about green roofs is something that I think just we really need in our industry of what great examples are out there, like so much of the other green infrastructure strategies that we've heard about already. So thank you for sharing your research with us. And I've also been working with Dr. Busolo on native plant selection for rain gardens. And so there's so much crossover between stormwater and native plants. And so our industries definitely need to work together more. And so thank you for your partnership in that. And we will hold our questions to the end to give a little bit more time in that Q&A. Next, our final presenter for this session is Paul Newton, the Partner and Design Manager for Agriburbia. Paul?
Howdy. Let me just get everything shared here and we'll get going. Sorry. Everybody see that okay?
I can see it great. Thank you.
Excellent. Excellent. So thanks for the introduction, Jessica. I've been working with Agriburbia a number of different fronts for a long time. And it's a pleasure to make a presentation here today. It's impressive. I was not aware of all the work being done at the Spur campus, and it's absolutely terrific to see what's happening there. We have been working in both the land development, design, and planning areas of new community development, and my background's in architecture and design and planning. And so we're always paying attention to how all of the infrastructure is designed and chiefly how water is being used. And it was about 10 years ago or so that we really came to realize that what we really wanted to work with was the food production and integrating that with land development principles in a way that they would work closely together and in a symbiotic way. So in this way, we've been building the infrastructure for the next generation of food. And we've been developing, I'll go through the technologies and design approaches and other things that we've been putting together in this presentation to sort of let you all know what we've been up to and how we might collaborate both in stormwater management situations and in other applications of green infrastructure. We've been lucky to work with a little bit so far with Dr. Busolo on a couple of grant applications looking to deploy agriculture and intensive agricultural production on green roof systems and locations. So hopefully that'll be something that we can all put together in the future. In general, we've been lucky enough to work with some pretty intelligent people, which is always really nice. And so we often think of ourselves as a league of world-class basketball players, but pretty thin team. And we've structured our company to be able to look at the sort of all the different essential parts of implementing compact intensive agriculture and transforming agricultural practice in that way. So we have three sub companies under one big holding company, where we have a development company that's really responsible for design and planning and entitlement for integrating agricultural solutions into open space and other into open space areas, and working that through code compliance or code zoning modification in order to be able to make those things happen. We have another company at ABURB Design Build LLC, which is about really executing these things in the built environment and developing technologies to do that. And ABURB Operations, which is the other arm of our company, which has allowed us to actually really test some of the hypotheses we've been working with in terms of how you could bring compact intensive farming up to scale in a way that could feed us all and use less water and get into a kind of a more controlling position in the overall food supply chain. our initial tagline, I think when we really started working with food, was the intersection of food and real estate, which has now kind of grown to agriculture and development. And the intersection of those two things we really consider habitat. And what has recently, in the last like 4 or 5 years or so, come to the forefront for us is this link between food and health and wellness. And so we're beginning to integrate, holistic healthcare practices and functional medicine into the design and planning of the projects that we're working on. And really we have this intersection of all these things, which we believe actually the green infrastructure of the future is about health infrastructure. So we really are looking at this as I guess we're sort of the macro level water use kinds of people if I can bring this back down to our audience, but really the intersection of healthcare and agriculture is about sustainable agriculture, and healthcare and development would intersect at a well-building institute. Like, how could we make buildings and environments more healthy and suitable to live in? So one of the things we did about 10 years ago, this is actually 10-year-old data, but to be able to frame the problem, the connection really between food, health, development, and so on. This is some graphs people will be very familiar with, but when you overlay them, they're pretty interesting. This is the growth in population over the last 60 years or so, and then trends in farm population. Farms are reducing in size and quantity, and then the percentage of farmers in the U.S. labor force. We've been losing farmers continually. I'm an architect and a designer, and I can tell you that there are more architects and designers than farmers out there, which is kind of spooky. But the number of farms has also dwindled considerably, specifically small farms. A lot of those have been absorbed into industrial farming operations. There's very few new farmers coming up through families or other by other means to be able to practice farming. The barrier to entry is significant. And the other health aspect is that our diets are getting worse, and so we're getting larger. We're eating the food that we're consuming is poorer quality. It has to travel further. It has to be preserved in a way that it didn't have to before. And the health cost, as we all know, has been growing. Significant increase in healthcare costs over the last 40 years. And if you put all these together, we begin to see a little bit of a correlation here between the poor quality and less agricultural production, maybe leading to increasing health problems and inability to sustain the consumption of food that we're working with. This is a study that was put together by the American Farmland Trust. Again, this is probably about 10 years ago, and basically what they arrived at was that in the U.S. We're basically 13 million acres short of fresh fruits and vegetables to meet the current population dietary recommended intake by the USRDA. Right now in the state of Colorado, a population of 5 million. We calculated, this is back in around 2012, that we need 208,000 additional acres of land in production in order to sustainably meet the USDA dietary allowance. And this 208,000 acres of farm could potentially, in our minds, create 83,200 jobs. So there's another economic cycle here to consider. So our real mission is to find a way to create 30 million new farmers. And these farmers are not going to be born tomorrow. These are people that are already out there that don't know they're going to become farmers. And we're looking to develop ways to ease people into this profession and make that part of their lifestyle and way of life. So this is our national call for new professional commercial farmers. and they are everywhere. I'll go into a little bit of this, but the decision drivers for creating new farmers is changing. Resilience is, as we all know, with the COVID epidemic in the last year and a half, that normal systems that would normally respond to stresses and environment and so on have been challenged, and so CEOs now are looking at energy, water, and food as priorities to be able to manage the resources adequately, and health and wellness is emerging too, like just in terms of changing the medical industry and common practice, or what would maybe be considered traditional practice. I'm not sure what iPhone 25 is about, but I'm sure it'll be here and we'll all be excited. But the agrobarbia types of development or application of our solutions can happen in two different ways. The big two types, basically private development, which could be open space, public farms or civic farms, private development, which would be private housing developments like private steward farms. These are edible landscape farms, or AABEs, which we refer to as agriculturally augmented business enterprises, and office and industrial parks. So these are largely these are development plans that would go through the typical entitlement process and would designate or integrate agriculture into their into their approvals, basically. The other opportunity we see are existing landowners and institutional landowners that already have significant arable land at their disposal. These include like hospital campuses, school districts. We've actually done several projects in the Denver public school system that have where we've farmed half to whole acres of food for the students in the free and reduced lunch program, and academic higher ed campuses, college campuses, churches, and any other areas where there's probably a ton of lawn being mowed that could probably be food and be productive. So we really view agriculture as infrastructure, and we believe that in the future that agriculture will be another component of infrastructure that everyone will rely on. This is about making the food we eat more ubiquitous, available and plentiful, and of the highest quality and available locally as much as possible. So this is one particular project that we've been working on for a long time in Adams County. It's called Adams Crossing. It's finally going in through the entitlement phase, and this is an area of the development around Second Creek. This is only a few miles from Denver International Airport, where through the use of agriculture, we've been able to capitalize on the open space available there, and we have 12 small farms that are sitting just outside the floodplain, and they're able to cultivate and harvest local food within the floodplain and provide an area for storm surge and other things that would perhaps make that all very appealing. So this is 48% of this particular parcel is actually in intensive agriculture. We're also deploying geothermal and solar technologies at this property to manage some of the cultivation, the energy used for cultivation and heating. And it's also a LID, low impact development project. So it's really meant to capture, filter, and reuse stormwater if at all possible. This is another project that's just to the north of Adams Crossing that is also going through entitlement right now. This is a Brighton Sports Center complex where we're looking at deploying a green roof system on top. This is actually going to be a sports and recreation complex with reconfigurable football fields and soccer fields and baseball fields. And but it's also meant to be a medical office building and house some medical office services as well as a charter school. And we're looking at doing, classroom activities out on the roof and holding outdoor classroom activities up there. This picture actually in the lower right-hand corner is a project that we have completed. It's been implemented. It's a green roof in West Denver at the Lake House development. This is actually a second floor roof for a residential long-term, like a senior residential building. A lot of the rooms here have a look down on the garden, and we pull close to, wow, I'm not sure exactly the numbers, but it's several thousand pounds of food a year off of that green roof that is then served and available to residents. And it's fresh food available right outside their window, basically. We've also been working on this building, and we call the Farm Kit, which is a SIPS building, a highly energy efficient building that's basically a barn you can live in or a house you can farm out of. But it's meant to be one of the first steps that a new farmer could take if they have a piece of land, would like a place to build a farm. That this building has all the components within it to be able to be used for farming and preparing food, processing food, and selling food. It has a commercial kitchen on the first floor, residential amenities on the second floor, and so basically it's a place that actual real farming can happen and give you the additional infrastructure, building infrastructure to make it work. This is these are the different kind of business models we've been working and developing with to utilize in deployment of farm kits and new farmers. Occupational therapy center, natural dental care. We have a dentist who wants to grow their own mint there. Farm-based daycare, a terrific place to be able to have your kids spend the day while you're working. Chiropractic services, really, this is where some of the healthcare began to intersect, and these are the things that Jeff Bezos can't deliver to your front door packaged in cardboard. So there's still a need for some of these things. Our general research and planning agenda, we are actually landscape architects, planners, and geologists originally, and so we try to approach all of this as scientifically as possible. But by doing the applied research to look at how we could do compact intensive farming, we developed the community food fraction, which is really a ratio of population to caloric capacity and caloric production. If you have a housing development of 400 homes, where are you going to grow all the food to feed the 2.5 people in each home? That's a measure that we could make. And we're also looking at the calories per acre foot of food production that we could make on an acre foot of water, and translating food production as a function of water security and agricultural infrastructure, like how this actually can actively happen. We're trying to approach a carbonless food production model with these things. So in terms of the use of water, this has been a pretty interesting exploration for us. Basically, about 73% of the water that's available to use in agriculture goes to surface irrigation. And so if you were to think about how to reduce the use of water in a general sense, that seems like maybe the first place to start. All the designs for the compact intensive farming model that we have are drip irrigated, super duper efficient, pretty much the top line of irrigation management and control. And this is another interesting study produced a little while ago. This is the embedded water in food. So this is in the lower right-hand corner. This is how much use per day we use as domestic water. And this is the amount of water that's used in industrial activities. And for the production of food, this is the amount of water used per day in production of food in the United States. And it's a really fascinating graphic to understand. It's that really there's a lot of work to be done in terms of better water management for food production in general across the board, and other ways to be able to conserve water in this regard. Basically, we have another arm of technology development that is both site planning and farm kit site technology, building technology, and production technology, which is really the bottom one here. Farm kit production technology, which we call the trellis, is a compact intensive farming tool to augment production. It can be deployed easily over fields, open level fields, but also in rooftop applications, which we're looking to do in the next few years. This is essentially a small or a linear greenhouse, essentially, that could extend the growing seasons, maybe augment some of the production in different cases, as well as provide monitoring and analysis on a daily basis with AI and camera visual recognition of how the plants are doing. We believe this is probably the key to something that will change how the food markets actually work, how food's produced, and find ways to grow food closer to ourselves that will sustain us more easily. So we're in this, because we've been looking at the whole picture. We're a transdisciplinary firm. We're looking at what do we need to eat, like what constitutes very good food, and where do we eat it? This is a geography question, and how to have land there, water there. How do we bring all these things and make them available in villages and communities where they're plentiful, so we can have an abundance of food. We always sort of leave with this one, this quote from Thomas Jefferson in 1785: "It's not too soon to provide by every possible means that as few as possible shall be without a little portion of land. The small landholders are the most precious part of a state." We hope to rekindle some small landholders and professional farmers to transform our urban centers and suburban areas and open space, so that we can all feed each other in the future. And that's the end of my presentation. I hope it was informative, and certainly let it open for questions. Thank you.
Thank you very much, Paul. You all came to the Stormwater Conference today. Didn't know you'd learn about food production. That's one of the things that I love about Stormwater, is how integrated we could make it as we move forward. Food security is one of the major components of something we need to be thinking about, how disconnected we are from our food, where it's grown and how it gets to us, and integrating stormwater management and food. These are the kind of ideas that we need to move forward in sustainability. So thank you to all of the presenters. I would like to invite you all back to be able to have our Q&A session that will be led by Sarah. And if Paul, if you can stop sharing your screen, and then everyone, thank you. You can see all of the presenters. So we have some great questions in the Q&A.
Yeah, thanks. There's been a lot of activity in chat. And so some of these have been addressed, but I'm just going to kind of roll through them. The first question came in during Holly's presentation, but there may be input from the rest of the panel. So also Frank at Northern Water provided a good link here in the chat queue. But are there any green infrastructure that would work well in arid or dry areas like the Western Slope? Seems like some of these concepts and ideas are for areas that get decent precipitation. We would likely need to water year round just to keep vegetation alive.
Well, I can start and others can chime in, but we do have a pretty good emphasis on using native vegetation. And what I'd really like to see more, and I kind of gave an example during my presentation of how you bring water into some of these practices. For example, using a level spreader to bring runoff into a bioretention basin spreads that water out more, and that benefits the vegetation. But these are all designed in areas, they're all designed to collect runoff, right? So let's take advantage of what we get and what we've seen. You know, for example, the site at Iris, we have an acre draining into this bioretention basin, and it's no longer irrigated.
You know, the one thing I would add is that, you know, for a number of years, the Pima County Flood Control District down in Tucson has been hosting an arid LID conference. And I don't know if they've been doing it in recent years, but for a number of years, they were doing that. And I remember going down a few times, and I know that in Tucson, they've developed some really, really neat stuff. So if you're in areas of Colorado where, you know, you get less than 10 inches of precipitation annually, that may be a place to look for some additional guidance, because it's very challenging. I mean, you can still do irrigation, right, and support it and use natives that are adapted. But there are some manuals that are out there for very dry environments, such as Tucson. So that's a good resource. But like Holly said, you know, it's all about trying to make that stormwater go as far as it can. And even when water's more space limited, that's all the more reason to distribute the water that you have to sustain vegetation or at least soil moisture.
And I would add to that, there's so many benefits to having vegetation, and there's a lot of different water sources we can use for that. We can think about gray water, treated wastewater, obviously the stormwater, collection of all these different water sources, and support some of that plant growth, which offers a lot of urban livability and ecosystem benefits.
Great, thank you all. This question I think was partially answered, and Holly put a link in for this, but this came in during Sybil's presentation about the Water Technology Accelerator Lab at Spur Campus. So do you know if there's any water quality testing protocols proposed for use at the site? So I'm assuming the laboratory space, and the suggestion that it would be great if the testing protocols were similar to already tested SCM, so the results could be easily compared. And Holly, I think you addressed that.
I addressed it and Holly didn't.
Oh, okay, sorry.
Oh,
Okay.
I did put something into the chat, but Craig put something in better. So there's a new ASTM for this, which is fantastic. And I will add it to the link so it's there again. This is more recent than the guidance document that I had added, which is also a good one. But the ASTM link is worth looking at.
You know, I'd also mention that the International BMP database has some monitoring guidelines that are useful. And, you know, that International BMP database, I think most people probably know about it, but it has hundreds of different stormwater control measures in there. And so to the extent that you can collect monitoring data in the backyard, you know, with those bioswales or with the rainwater harvesting or other things, getting data that will be compatible and that can be entered into the BMP database will really leverage the ability to compare that. And I think that is fairly easily done. It's just a matter of how you monitor flow and how you calculate pollutant concentrations, typically as an event mean concentration. So there is a lot out there, and I think it's a real good question, because having compatibility of data so that we can compare it to other sources and really understand how this system works compared to others is going to be so valuable.
Great, thank you. So we did touch on, you know, the multi-year testing program. So I believe that question has been addressed. One question we didn't get to about the backyard space in Spur Campus was proprietary products and testing these in the facility. The participant is wondering if the site allows for temporary BMP product testing.
Yeah, so the lab space is a great space to test kind of, I guess, novel technologies for stormwater control development, but there is limitation on space in the backyard in terms of adding a lot of new technologies. There could be flexibility over the future, I think, in adding new technologies, but I think as far as testing new technologies, that the high base space that we have is very large. I'm not sure of the exact square footage, but you could actually build a test unit for a green infrastructure system and run tests in there that would be pretty large scale. Like I'm thinking you could have like easily support a 20-foot by 20-foot or even 30-foot by 30-foot kind of test plot within the high base space to test technologies. And again, we'll have the stormwater collected and stored that we could simulate events using real stormwater, but simulate events using that stormwater.
Just wanted to chime in really quickly with a quick comment on testing manufactured devices or manufactured SCMs. The ASTM specs there were for manufactured devices and public domain devices, and that's really tied to a national verification of public domain and manufactured devices called STEP that I'm sure a lot of you are familiar with. Andrew, of course, is familiar with this. I just want to mention that in the infrastructure bill, there is funding. They're establishing these centers for excellence that will test all of these devices around the country. And with the kind of big need here that I'm assuming a lot of people on this call is having these devices tested in conditions relative to Colorado is a big need and gap that's out there. So just want to put out there that I don't know much about SPUR. I was glad to learn a lot about it. Maybe SPUR could be one of these testing centers of excellence through the STEP program that was also kind of working with these ASTM testing protocols. I can email a little bit more offline about that. It sounds like a great opportunity.
That's great, Craig. Thanks. I mean, the foundation of this Water Innovation Center is really to foster innovation and commercialization of technologies. And we're really excited about the potential to test different technologies in different ways. And I think that there's a lot of flexibility built into how we can do things on the SPUR campus to enable those things.
Great, thank you for that, Craig. We'll probably follow up with you afterwards for some more information about the STEP program. This could route to either Sybil or Andrew. Any possibility that monitoring and research at the center will include quantifying roof runoff reduction, or excuse me, quantifying runoff reduction, including interception and infiltration from tree canopy cover?
I'll go ahead and start, and then Andrew can supplement. The idea of this backyard at the hydro building is that we can support any types of research and monitoring activities, and we want to try to monitor everything and as much as we can. So I think there's lots of opportunity to monitor things with respect to, like we've talked about, evaporation, infiltration. We're really designing the whole setup to be able to measure the entire water balance of the system.
And I'll just pile onto what Sybil already said, but you know, and with the landscape plan, I'm not sure exactly where the trees are, how many there are. But you know, I've been actually doing a little experiment in my backyard, and I've tried to crowdsource this thing before to no success. But really all you need to do to look at interception from trees is you need 2 rain gauges, and you can even get the $5 ones you get at Home Depot. You put one that's not under the tree, you put one that's under the tree, and every time it rains, you measure them both and you figure out what the interception is. And it's frankly really interesting because a lot of times people think of interception as a percentage of the rainfall, but it's not. It's a fixed quantity. I mean, there's only so much water that those leaves can hold before it'll fall through. And I mean, that would be easy monitoring to do at CSU once the trees mature a little bit at the hydro building. But it would be really cool if the 100 people on this call went out and just put rain gauges on their backyard and sent all the data to Sybil, because she could write a really cool paper about it.
That's a great suggestion. You guys have homework for today. Andrew, this came in during your presentation. So what is driving the more recent emphasis on bioswales in lieu of bioretention?
Well, I think, and I saw that question in the chat, and it's a good one. You know, I think landscape architects like to call swales bioswales to reflect the plants and the living nature of them. You know, in any swale, even a grass swale is a bioswale, right? It has soils that have microorganisms and macroorganisms in it. It has vegetation that's alive. So really, even just a regular grassy ditch is a bioswale. Now that is different from bioretention. Bioretention is designed to actually hold the water quality capture volume and infiltrate it into the facility. So a bioswale tends to mimic bioretention because it has a lot of the same elements, but it's really intended to convey the flow without detaining the water quality capture volume. So you get infiltration, but you're not holding back the water quality capture volume. And I think we'll clarify that a little bit in volume 3, because we do have a little something in the manual about what's called regenerative conveyance, which is kind of using conveyance channels to provide treatment. And that's still really kind of an emerging technology in Colorado, but that is kind of what I think people often mean by bioswales, but they are something that is different from bioretention.
Great, thanks, Andrew. This came in during Jen's presentation, but Sybil might have something to chime in as well. So we're wondering, could the gray water from sinks and showers be used to establish these green roofs? Then there might be not such an increase in potable water demand. Any thoughts there?
So I'll jump in first. I did answer a little in the chat, but not everyone can see all of that. So the first thing that we actually tried to do at Spur Campus was be able to use reclaimed water, but they're not going to be able to plumb that water from the facility there. It's just not, the infrastructure's not there yet. So we even talked about maybe having water trucks shipping, taking that water that starts to get to be of higher energy costs. So we're not as interested in that. Gray water, I'm definitely quite open to, but I think there are some restrictions outside of my sort of knowledge space on that.
Actually, gray water irrigation is allowable. It's a little bit more complex at a commercial facility like this, but if there weren't a lot of access to the area, particularly by humans and kids and those kinds of things, then gray water irrigation would likely be allowable through the law. Gray water, we did a study, gosh, it must have been 10 years ago almost, funded by Water Research Foundation, that looked at the impacts of gray water on plant health and soil quality, and generally found that gray water supports plant growth very well. There were a few plants we found to be sensitive, but you could select for the appropriate vegetation. And like I was saying before, it's a really great way, I think, to use these alternate sources to provide the water for this vegetation, especially because there's those building cooling benefits that occur as well. And when we're using an on-site water source to do the irrigation, and we're not decreasing our traditional supplies of water, taking potable water, municipal potable water to do that, then a lot of benefits are achieved in terms of efficiency, and then we get the cooling benefits as well. So I think that we could definitely look at gray water use for the rooftop. I know that they're already planning to use it for flushing toilets, and I'm not sure there's really enough gray water generated in that building to do both of those, but it would be feasible in buildings to think about that. And I think it's a really good option.
Thank you.
I have an additional question on that. So will the green roofs on the Spur campus be utilizing some of the collected rainwater to irrigate them as well as the native plant plots that are already going to be irrigated with those?
No, just what lands on it. That would be an issue with a downstream water law. So, but what Sybil was mentioning about gray water, that would be absolute dynamite. I mean, we're not using real soils up on the green roof, so we're probably not going to get an accumulation of any impurities that are going to really affect the plant growth. So, man, we might as well get Rachel, to plumb that gray water up there if we could get that to happen.
That would be a really nice demonstration.
And Jen, I know you were answering quite a few of the comments that came in during your presentation on the chat, but maybe we'll just kind of abbreviate some of your responses. So can existing buildings do a green roof without major structural work to keep the roof from collapsing?
Good question. Yes, we always employ structural engineers to make sure on retrofit, but we can retrofit most buildings. Lots of 100-plus-year-old buildings in Europe already have green roofs put on them. There's no reason. We also use very lightweight materials for that. And green roofs don't leak any more often, since that's a common question too. We make sure we design them correctly.
Great. And then there's a question about life cycle cost analysis. So Sybil and Jen, you can chime in here. Has life cycle cost analysis been done on green roofs? And if so, what can we deduce from it for Colorado specifically?
Yeah, that's a great question. So I'm the editor of a journal of living architecture, and we had a paper not that long ago that came through on that. There's actually a couple of other ones that are about 15, 20 years old as well. So there are plenty of papers out there, not specific to Colorado, but I agree with Fossil that we should have something that's Colorado specific. So I'm looking for funding, if anyone knows of any, to get our ag economists to do a life cycle cost analysis for us.
Thank you.
Okay. Now, what about using green roofs in high mountain towns? Oh, Basil, did you have a follow-up? Sorry, didn't mean to cut you off if you did.
No.
Okay. Okay, the use of green roofs in high mountain towns. Does heavy snowfall affect the plots, and can there be a slope on the roof? And furthermore, any considerations for historical preservation requirements?
Great questions. Green roofs are actually well suited to high elevation. The extra moisture in the winter is ideal for survivability. And then slopes can work for green roof applications, but gravity works against you. So it ends up being much more of a struggle. So if it is slope, I suggest low slope, so less than 10% or less than 10 degrees is the most ideal. And the last one was?
Historical preservation requirements and considerations.
Sure. So not every single building is going to be ideal for green roofs. And we have on the Green Building Ordinance Committee, we have the landmarks folks represented there from the city. So yeah, we definitely don't want to mess with any of those necessarily. It's just where we can do them would be ideal.
You know, one thing I would add in is some of the nicest green roofs I've seen in Colorado are up in the Aspen-Pitkin County area. And it's because you do get that good moisture, you don't have to irrigate them really, or maybe not as often. And you also get a lot more of the thermal energy saving benefits up there because they get a lot colder temperatures, and you get the insulation benefits. And from talking to April Long, who's the stormwater manager up there, you know, it's a much easier sell up there economically because of those energy benefits. And then you get the stormwater as kind of icing on the cake.
Thank you all so much. I think we're out of time for our Q&A. We're going to have our next break. I'm going to share my slide here. But I just want to say again, thank you to this panel, giving us real life examples of green infrastructure in action. And also the upcoming research is so needed to really inform those future planning projects. So thank you to all of our wonderful panel speakers. We are going to now have a coffee or snack or stretch break from 2 to 2:30. If you are going to apply for the continuing education credits, please fill out the next quiz that Sarah will put in the chat for you. And then join us back at 2:30 for our final session of the day, which is Innovative Stormwater Education and Training. Thank you all. And if your question was not answered during our Q&A, we will be getting those answers for you and sending them out. Thank you.
Yeah, I think we just had one left on my list, which I just dropped into the chat queue. So if any panelists feel up to answering it via chat, that would be awesome. The quiz link is in there as well.